name is Suhaimi with metric number 1610684. Today, we are going to present on finding the river water quality using advanced mathematical methods. Humans retain about 60 to 70% of water in their body. Because of this, the water intake of humans should be clean and nutritional. Having polluted river water is not only harmful to humans, but also to the Mother Earth. For this project, we are going to present on finding the water quality of a lake which is called Lake Baikal. So what is the relation of a lake and a river? Rivers flow in and out of a lake which is an enclosed body of water which affects the quality of water. Therefore, knowing the quality of the water in the lake is also important because it is the supply for domestic, agricultural and industrial activities. The objectives of our project is 1. To solve the lake water quality problems by implementing what we have learned in advanced mathematical methods. 2. To find the time for the pollution level to reduce to half of its current level by using Laplace transform. 3. To graph the concentration versus time graph and determine the time by using Wx maxima. For our scope of study, we focuses on determining the water quality of a lake measured in years. This study involves the inflow and outflow between a lake and a river. Laplace transform is the method that has been used throughout the study to find the time taken for the water quality to deplete half from its current quality.
I am Siti Najihah binti Muhammad Shuib with metric number 1612342. I will explain about mathematical model. Russian ecologists had warned that the Lake Baikal is turning into a swamp. A scientific expedition discovered that 160 tons of liquid waste are produced every season in Baikal Bay. This happened because of a few causes. The causes are tourist camps, water transport vehicles, and an increased number of alien water plants. Firstly, a growing number of tourist camps in the area are unwillingly contributing to the pollution. Next, according to the head of Baikal Environmental Wave, a large contributing aspect of the pollution to the Lake Baikal is because of the water transport vehicles such as ships, boats, yachts and other vessels produce approximately 25,000 tons of liquidities annually, but only 1,600 of them end up at the proper disposal facilities. So the waste that dumped into the water, into the lake, started the growth of the alien water plants such as Spirogyra that never had grown there before. So for this project, we make the following assumptions. First, there are no longer heavy pollutants discharged into the lake. Second, the flow rate are constant throughout the year. Third, when a liquid enters the lake, a perfect mixing occurs and the pollutants are uniformly distributed. Fourth, the pollutants dissolve in the water and enter and leave by inflow or outflow of the solutions. So our problem is the volume of Lake Baikal is 23,600 km3, while its depth is 1,642 meters deep. The current concentration is 1.8 milligram per kilometer cube. So we wish to know how long it will take for the pollution level to reduce to half of its current level of pollution. So here we know that the volume of water in Lake Baikal is which is V equals to 23,600 kilometer cube. The initial condition is when time equals to 0, the concentration equals to 1.8 milligram per kilometer cube. Next, the rate of flow and outflow of the Lake Baikal is the same, which is R in equals to R out equals to 60 km cube per year. The general equation is dy over dt equals to rate inflow or rate outflow, where dy over dt equals to flow rate of liquid, y equals to the concentration of pollutants in milligram per kilometer cube, and t equals to time in year. That's all from me.
The next part is the manual solution. First of all, my name is Siti Nordiana binti Imam Fauzi, metric number 1618928. Then clarify again, dy dt is the flow rate of liquid. Since we assume the rate flow is constant, rate inflow equals to rate outflow equals to 60 km cube per year. And the initial concentration of pollution, where T equals to 0, is 1.8 milligram per kilometer cube, and the volume given is 23,600 kilometer cube. And here we have the equation, the volume rate flow equation, where dy dt equals to negative 60y per volume. The negative signs indicate the rate inflow minus the rate outflow, but we only consider the rate outflow of the lake. Then we move it to the left hand side of the equation so that the equation would equal to 0. Then we perform Laplace transform into the both sides of the equation, and then we have the derivative form of Laplace transform into this form of equation. Then we substitute the value of y into the equation, and then we factorize to get ys. Then we perform inverse Laplace to both sides of the equation to get the value of y, that is 1.8 exponent negative 0.00254 t. Since we want to know the time taken for the pollution to reduce to half, we now have the new value of y, that is 0.9, from 1.8 to 0.9. Therefore, we substitute the new value of y to the equation that we just get just now to get the value of t, that is 272 years.
Now, let's compare it with the computer-aided solution. First, we compute the initial equation that we have, that is dy dt plus 3y over 1180 equals to 0. Next, execute the Laplace transform to both sides of the equation. Then, substitute the value of y. Compute the inverse Laplace to get the equation of yt. Lastly, compute the command to plot the 2D graph. As can be observed, the result is similar to the graph obtained. The graph shows a negative exponent curve which declines with time. At 0.9 mg per kilometer cube, the corresponding time is approximately 272 years. This shows that to decrease the concentration of pollutant in Lake Baikal to half of its initial concentration would take 272 years. The graph reaches a steady state at approximately 2,500 years.
My name is Hanis Shamimi binti Muhammad Ali Hanafiah with metric number 1616674. I will conclude our project. In a nutshell, the focus of our project is to determine the quality of lake water, specifically Lake Baikal. In order to know the quality, primarily we need to know the duration for the pollution level in Lake Baikal to reduce to half of its current level. Regarding to this problem, we have used the method of Laplace transform for the first order differential equation in determining the general solution. Then we perform the inverse Laplace to get the concentration of pollutant at time t in Lake Baikal. Subsequent to that, the time taken when the amount of pollution is reduced to half is determined. Lastly, we verify our solutions using Maxima and LaTeX software to compute the graph and also to complete the report. Last but not least, we have listed out some recommendations through the process of completing this project. We have analyzed that researchers need to produce and develop models to be implemented in practice to lessen the time taken for the pollution to reduce to half. Moreover, it is important to use the right technique in solving the manual calculations. Lastly, to have the knowledge in using Maxima and also Laplace software is also important because it helps us in implementing the mathematical models and numerical models.